Thank you, Kathy. And we are recording. So this session is all about priming you up to actually undertake your practical safe system assessment. Well, it's sort of a mock safe system assessment. I'm going to give you all the information how you actually do it. Now, all those principles that we've been talking about are super important in doing it, but this is more the mechanics of doing it. But I'll point you at some safe system assessment guidelines, as I mentioned, how to complete a safe system assessment matrix. And that's sort of the meat of a safe system assessment. How to write up the report, and how to categorize treatments into primary and supporting. So another little tricky little bit that you've got to get your head around. But a little bit later in the session, Kathy will show you a couple of source documents that we have in the learning management system that will help you. But this session does have, I suppose, a lot of me just explaining how to do different things. And I will sort of flag and highlight things as we go that people commonly get wrong or that are really important that you understand. So you might want to have a pen and paper ready or something, or have a Word document open on the side, because some of them are quite important. But we've gone through nicely these principles of the safe system and the way that New Zealand's sort of forging ahead, and that's really important to understand. The safe system assessment methodology is just one tool to help implement this whole philosophy. And we did spend super amount of time on exposure, likelihood, severity. You did some really good assignments. Everybody that submitted, which is the majority of you, have got your feedback, you've got your marks, and there's probably a few things in there you're still just getting your head around. Hopefully my comments helped you a little bit. Always happy to chat further if you're still confused. I think by the end of this module, you'll go, okay, I get it. And exposure seemed to be the one that caused the most trouble, and that's understandable. We talked about physical forces and the human body's ability to handle forces, and we used these charts, but then we jumped onto this important chart within a safe system assessment, and these numbers are going to be very important as we tick along. So we'll be coming back to this, but really you're going to be wanting to use this in your safe system assessment as a bit of a guide. And it won't cover everything. There's a bit more guidance in things like this and this, and I put them all at the start of this module just to have it all easily available as well. Okay. How do we actually do this assessment? Well, the safe system assessment methodology is all housed in this safe system assessment framework, which is an Ostrodes document. It's a 2016, or is the end of 2016 document, and I wasn't one of the authors of it. I was on the working group for it, and we had some really great discussions about it. And there's bits in there that were sort of unknown at the time or hadn't been done really, and we've learned a lot since the release of this document, and we've adjusted the process and the like. But I will be sort of taking you through the content of this. So we've put a copy of this into the learning management system that you could have a look at. And then there's some other documents. This document sort of breaks an assessment up into the objectives of the assessment, the project context, the matrix, the safe system assessment matrix, and treatments and treatment hierarchy. So I'll be going through those. But I suppose one thing to note is the objectives of the assessment can play an important role. We've, as an industry, sort of come into line with generally what safe system assessments are used for, and they're used for assessing a future road project or design for how well it aligns with safe system principles and what can be done to make it align better. We do, well, there's a bit of people using the safe system assessment for existing roads, and that works as well. There's also the ability to use the safe system assessment at all sorts of levels. Like you could use it at a whole of program level, so a maintenance program, a congestion easing program, whatever it is. You could do the whole program. You could do a whole township, like a remote township or a mine site under this methodology. So there is a lot of scalability to the assessment methodology. And there's also a lot of variation in the depth of assessment you could do. You could take one intersection and your safe system assessment could be many, many months worth of work. Or it could be relatively quick. And so it's in industry, we've found a sort of appropriate place, I would say, between there, where it's a good look at an intersection design or the like, but it's not trying to do a PhD on that intersection. So since the release, I mentioned there was a couple of areas where people were a little bit uncomfortable after we started using that guidance heavily and started finding all these particular scenarios and situations which didn't make sense or hadn't been thought through. And that's just because nobody had really done safe system assessments before. One of my colleagues and I were doing a thing we called safe system audits, which were sort of the same but different. And there was some people in Western Australia doing some stuff, and but yeah, when Austroads released that, we got a new methodology, and then after using it for a bit, we discovered some issues, and so Victorian government and South Australian government released their supplements or their own guidance, which follows pretty much the Austroads guidance, but then clarifies some of those unwritten things and I suppose makes commentary around things that don't really work in the Austroads methodology. Now, we hope Austroads will do another version of the assessment methodology, but that may be a ways away. So industry now has a bit of a practice of how these are done. New Zealand is following that general practice, and that's what I'll be talking you through. But you'll get that from, well, I should say these two documents are the same. They have a different front cover, and but they're the same content. So we sort of follow the Austroads, then use these documents. And then there's those final, I haven't put it in there, the fact sheets that we've produced, Safe System Solutions has produced to cover off even more things that aren't covered in these documents. So just trying to fill all those holes where people have come across things and said, well, how do you do this? And, well, it's actually not covered anywhere. And we'll get some people in the room and we'll have a chat about it, and we'll work out what we think the best way to go forward, and then we'll be consistent with that. So we put a fact sheet out on a series of those. Okay.
Ken, can we jump in with a quick poll question for everyone? Find out where they're at with safe system assessments.
That's a great idea, Kathy. Let's do it. Thank you. There we go. What has been your involvement in safe system assessment? That's a good idea. Maybe everybody down the bottom there lives, breathes, and eats safe system assessments. I don't even need to run this module. That'd be nice.
Not a bad idea for Friday. But yes, okay, just jump in and answer that poll question. And there is no right or wrong answer. It's just your experience.
Yeah. Thank you for reminding me, Kathy.
That's all right, Ken. That's what I'm here for.
Okay.
I'll just give it a few more seconds. Good. All right, we might close that off now, unless anyone's still really debating over what they want to put in their answer as. We'll end that. And let's have a look.
Okay, so
nobody does live, breathe and eat safe system assessments. So phew.
a couple of people have done them. That's nice.
Yeah.
Really good amount have had them done on one of their projects, which is, I suppose, shows the amount they're growing and being used as industry practice, which is great. A lot of people heard of them and a few people nothing. Safe system, what now? That's okay. Start from the start. Thank you, Kathy. So when you're doing a safe system assessment, the first thing to do is to gather really good understanding of the context of the project. Now, Austroads came up with these prompt questions, and they're in Austroads, the Safe System Assessment Framework, the document. Now, you might want to ask other questions, but these are some good ones to get a, I suppose, rounded context of the project. So, or the proposal, what they're planning to do. What I tend to do is, if I'm in a safe system assessment team, I'll get these questions and fairly early on send them over to the project manager or designer or whoever we're liaising with and say, can you collect information around these questions, write some comments in to the in next to these, and give us any documents that are relevant. And then I may also organise an early sort of workshop / meeting to go through and have them explain some of the context of the project, why they're doing things, what are their constraints, what have they committed to already, and you can see the questions there are aligned with that. What is the reason for the project? They're trying to address something in particular. What's the function of the road? What's the speed environment? What road users are present? What's the vehicle composition? They'll ask about movement in place or one network framework. Generally get an understanding of what they're trying to achieve. Because we, in our safe system assessment, will eventually make some recommendations or some things for them to consider to improve the alignment with safe system principles of their project. And we want to do that understanding the context of their project, what they're trying to achieve and the like, and see if there's ways we can have really high alignment with safe system principles and help them achieve their objectives as well. So there's a fair bit of work done in the early stages there, getting your head around the project. Now I'm sort of jumping right to the output, one of the sort of key outputs of a safe system assessment. And then I'll work my way through how you arrive and get these sort of outputs. But what you can see here is sort of one of the end products of a safe system assessment, which is the representation of the matrix, the scoring. And what this shows is the red bars. The red bars there are the existing conditions, what is currently out there. Okay. This one then has 3 options, it looks like. So they're considering 3 different things at this intersection. One thing they're considering is a roundabout. One thing they're considering is a modified T intersection with traffic signals. And the last is a standard T intersection with traffic signals. And you can see here, we've got crash types: run-off road, head-on, intersection, pedestrians, cyclists, and motorcyclists. And then we've got this other category, which covers off things that are not accurately or not represented in any of those other crash types. Now, those are crash types. And so anybody who's been involved in crash reduction studies or black spot studies or looking at particular crashes knows that we sort of code crashes, and we'll call them a run-off road crash, or it's a run-off road crash, it's a head-on crash, or okay, that's an intersection crash, that's a pedestrian crash, a cyclist crash, motorcyclist crash. So if, for example, a vehicle goes through an intersection and hits a pedestrian, it's crossing at the intersection, we actually put that as a pedestrian crash. So that's represented in that. I mean, if you are imagining that and predicting that in the future, it's a pedestrian crash. Even though it happened in the intersection, we call it a pedestrian crash. The intersection crashes are just when vehicles strike each other in the intersection. I'll explain this a little bit more shortly. But these are crash types. Now, you can see over here, safe system alignment score. Safe system alignment score is about the alignment with safe system principles, but the lower the score, the better. So the lower we see those bars, the better. And you can see there, without knowing anything about this intersection or anything like that, you can sort of see where risk seems to be presenting itself. So I think cyclists are something of concern, especially at this one. Motorcyclists then tend to come out pretty bad always because of their inherent challenges. But you can start to see things and get ideas immediately on safe system alignment in different crash types. So let's show you how you get to be able to build that chart. And so here's a little mock-up of the safe system matrix, the safe system assessment matrix. Okay, and you'll be pleased to see that the 3 rows here are exposure, likelihood, and severity. Hence why we've been banging on about that, because you need to assess things specifically based on that criteria, and you need to be able to look at that intersection and know what bits and pieces are influencing. Across the top there, we've got those crash types that I just talked to you about: run-off road, head-on intersection, pedestrian, cyclist, motorcyclist. Now, these ones, the first ones here, they are for passenger vehicles and heavy vehicles. And run-off road, obviously leaving the road, hitting an object or rolling over. Head-on crash, obviously sort of striking head-on there when sort of traveling opposite each other. The reason I say that is because at an intersection, you can have some fairly head-on type crashes that we don't categorize as head-on crashes, even though sort of the front of the vehicles are head-on, almost head-on hitting each other, but one of the vehicles was making a turn or coming out of a side road or the like, and that's an intersection crash. Pedestrians, anything involving a pedestrian being the one that is injured. You're predicting all of this. So you're predicting a pedestrian will be injured. So it could be a car hitting pedestrian, could be motorcycle hitting pedestrian, could be cyclist hitting pedestrian. If the pedestrian is the one that's injured, it's a pedestrian crash. Same with cyclists. The cyclist is the one that's injured in your prediction of a crash type. It's a cyclist crash. Same with motorcycles. Now, other is fairly open in what it is, and you get to decide that. You may decide there's nothing else, and you will sort of basically blank that column out. But mostly it involves things like sideswipe crashes. it will involve rear end crashes if they're not caused by an intersection. So a back of queue crash is an intersection crash in the assessment methodology. But if it's a mid-block school crossing or something, and there's a rear end crash there, we'll put that in other. If it's a crash with animals, we'll put that into other. Railway level crossings, that's in other. That's probably about it. Although you might find something completely different. Now, things like mobility scooters or e-scooters and those sorts of crashes, you, I suppose, can make a decision as to whether you put that in pedestrians, which kind of meant to, I mean, they get categorized like that, but they're sort of different beast. Or you put them into and may utilize that other crash category for e-scooters or whatever devices you're really concentrating on. So pop your questions in if you have any around what we would categorize a crash and where we would categorize it and how we would do that. And then I'll jump into explaining now how we think through and get scores onto each of the cells of this matrix or table, if you just call it a table. I don't know if I always call it a matrix, but yes, a table. Any questions coming in there, Kathy?
Thanks, Ken. What about striking a parked car? Is that other?
Yeah. It depends a little bit on the scenario. You'd probably put that into other. I sort of pause there because there are situations where we've called it a runoff road crash, depending on the sort of configuration of the parking. Others are pretty safe one for crashing into parked cars. Yeah.
Okay, great. Thank you. That's all the questions for now. But if you have any more questions, please keep them coming through.
Yeah.
It's a bit different from New Zealand.
Sorry?
No, somebody's just commented it's a bit different from New Zealand, but I'm not sure what's a bit different from New Zealand. So, Haran, if you can provide some more input there, that'd be great. Not you, Ken, the comment.
Okay. Thank you.
Another question, are driveways, access ways counted as intersection or other?
Other. Yeah, you'll skew your whole scoring if you put driveways into intersections. So yeah, put them into other as well.
So the comment is parked vehicle is not other in New Zealand, but maybe it does depend on the context. Is that right, Ken?
Well, no. I'm sort of intrigued by that because what is it then in New Zealand? Is it categorized as a runoff road crash? Because that's the only other option within here. So we're not talking about like a DCA chart or the like. It's got to fit into one of these categories. So yeah, but yeah, so I'm just not 100% sure what the context around that is.
Haran, should I unmute you? Maybe you can, it might be easier to tell us what you're thinking. So I'll just do that. If you want to ask further question or clarify, assuming your audio is working. But if you don't want to, that's all good too.
Okay. All right. Well, anyway, yeah, this is a safe system assessment categorization. The debate could be around, do we pop it into runoff road or other, and that's it is a bit context specific.
Yeah, sorry, Haran's there. Did you want to jump in?
Yeah, it's we have a separate symbol for parked vehicle, so it's kind of a parked vehicle crash. We can directly identify parked vehicle crash.
Yeah, so that'll be in your DCA or RUM code chart and your categorization of crashes from like a crash reduction study perspective. I assume that's what you're referring to.
Yeah, that's right.
Yeah, no, that's good. So what we've got in the safe system assessment matrix is that we have to take all of those crashes and put them into these categories we see on the screen: run-off road, head-on intersection, other, pedestrian, cyclist, motorcycle. So you'll have lots of crash categories in your, is it DCA or RUM that's used in New Zealand, or something completely different? Crash code, something.
Yeah, crash code used in crash system analysis.
Yes,
database.
Yeah, okay. So there's lots of crash codes in there that aren't specifically stated in this table. So you'll have, crashes with workers on the roads. You'll have crashes with level crossings. There's specific. So we just sort of putting all of these into these categories, and then when we get to that one with crashes with parked cars, the question becomes, do we put it into run-off road or do we put it into other when we're doing a safe system assessment? And we're sort of saying most of the time it goes into other, but sometimes it might go into run-off road.
I got it.
Great. Thank you for jumping in and clarifying. That's good. There you go, everybody. You're welcome to pop your hand up and have a chat with us. And let's get some clarification around that for ensuring that we've all got our head around it. Okay, so what we do is we look at the existing intersection or length of road or whatever we're looking at, and we want to put a score into each cell of this matrix. And you can see there the first row is exposure. And so we want to know how many people are exposed to run-off road crashes. That's the first thing we're trying to work out. And we do this by using the AADT, the annual average daily traffic. And you often, or you should in most cases, be able to obtain that. People will know what the traffic volume is, the AADT. Might be a bit of a general, they've got a general feel for it. But you'll come in and you'll get a score, and it might be like an AADT of 2,000. Okay, so great. Okay, we've got 2,000 vehicles a day going along this road, meaning that the AADT is 2,000. And we say, well, okay, is that the number we put into this cell? The answer is no, you don't put 2,000 in there. You find the safe system assessment scoring reference sheet. Okay, and this is directly out of Austroads. And I've sort of reproduced it here, but you'll be able to look at it in the Austroads document or looking at the one we've reproduced for you. But you'll see here that we've got the score that you're going to use, and we've got some explanations here of exposure, likelihood, and severity. But let's have a look here. Let's go right up to the top here. A 4 is the highest score. And what does it say for a 4? Volumes of vehicles that might be involved in a particular crash type are very high. Well, the road is very long. Therefore, exposure is very high. For run-off road, head-on, and other crash types, AADT is greater than 10,000 vehicles a day. There you go. That's the key there. Greater than 10,000 vehicles a day. For pedestrian, cyclists, and motorcyclist crashes, we're talking about greater than 100 vehicles a day. Okay, so what did we say? 2,000 vehicles a day. Well, it's not greater than 10,000. So let's go down one and we'll see if that's it. What is a 3? 3 is for run-off road, head-on and other crash types, AADT is between 5,000 and 10,000 vehicles a day. Okay, no, not on that. Go with a 2. It's between 1,000 and 5,000 vehicles a day. All right. Go back. So you can see there that exposure, at least for this run-off road one to start with, is quite clear cut if you're given an AADT. You just look it up on that chart. That's it. Okay? And that should help a lot of you in terms of people who are having trouble getting their head around exposure, because that really clearly shows it's just the number. So head on then, it's also 2,000 vehicles a day. So it's also going to be a 2. The only time that your head-on crash would change from that is if you had a divided road that was separated with a physical, rigid median barrier, like something strong. Okay, so even with a central flexible barrier system, like a wire rope safety barrier system, I probably would still put exposure to head-on crashes at the 2,000. And the reason for that is we know that barrier is going to do an absolutely wonderful job in stopping a lot of vehicles crossing the road. But I do know that the barriers do have limitations in some very, very small percentage of scenarios of a larger vehicle hitting it, or a vehicle at a particular angle, or these sorts of things. And so there's this very small chance that one may breach that and head-on crash may still occur. Yeah, you've got to take it a little bit case by case, but certainly if you had a median island, maybe 5-meter median or something that was just grassed, you still have your exposure to head-on crashes. Okay, that's certainly going to help minimize the chance of it, but you've still got that exposure. That is a common mistake I'll see, is that in safe system assessment, is that the presence of some sort of physical curved median, and people say there is no exposure to head-on crashes. No. Well, we know people mount those, go across those, and head-on crash. We know that the presence of the median island will reduce the chance of that, but it certainly can still happen. So that's exposure. Now we get to intersection. And you can see there, it says the AADT for each approach. So what you're actually doing is adding that up. So we've got 2,000 vehicles on one leg. And maybe we're crossing an intersection that has another 2,000 vehicles. So what we do there is take our 2,000 and we would add another 2,000. And we're at 4,000. Is the intersection. When we go to this, well, 4,000 actually still sits within our 2 category, doesn't it? But if it had been crossing an intersection with 5,000, it would have pushed us up to a 3. So at 4,000, we still put a 2 for this one. Okay, then we get to other. And other is still usually driven by the AADT, so sideswiped or all that, depending on what it is. You will write a little description in here as to what that particular other crash type or types that you're thinking about. And we give it a score for its exposure, and it's going to be 2 there. Okay. Now we're going to say how many pedestrians are exposed. What's the annual average daily traffic of pedestrians? What's the number of pedestrians crossing or walking along the road? Now, this one is interesting because we get often really great information about the number of vehicles, the AADTs. They can usually give us AADTs for the last 30 years. When we ask for pedestrian counts and pedestrian numbers, we don't usually get that information. It probably tells us a few other things, doesn't it? But anyway, that's yeah. So what we often have to do in this one is make a call ourselves, and that can be through the fact that maybe we know the intersection, we know the area, we know how busy it is with pedestrians. We'll do a site visit, so we'll spend some time looking at the area and how many people there. We will talk to the project manager, people who know the intersection or the like, and we'll get an idea of what we think the pedestrian numbers would be. And we go back to here, and this is where we're looking down here at, say, the cyclists, pedestrians, motorcycle crashes, at less than 10 units a day is a 1, 10 to 50, 50 to 100, greater than 100. Okay, so perhaps the one we're talking about, is relative. It has a decent number of pedestrians. Maybe they come slightly in waves, peak hours, and there's more pedestrians and the like. But we think there's sort of more than 50 a day crossing there, and maybe it's somewhere in the 75 range. We're a bit not 100% sure. But 75 then gives us a score of 3 for pedestrian exposure. Then you might want to say in here, assumed based on, discussions or knowledge of the area or the like, and we've taken a 3. We'll just go back to this for a second. In here, it says where you're not given numbers, you do rely a little bit on the wording there. Volume of vehicles are high. And moderate for a 2. Moderate, high, very high. So you want to sort of making your judgment call around that. So then you look at cyclists and you say, well, how many cyclists have we got? And again, you might be given numbers, you might not. You end up maybe with a 2 there for cyclists based on the fact that you know the area or you know what it is. And motorcyclists, again, maybe not given the numbers. You can generally say between 1 and 2% of AADT would be motorcyclists. So in that case, we'll give it a 2. So you're really using those numbers. And it's, apart from the fact that sometimes you need to make a little bit of a subjective judgment call on the number of pedestrians or cyclists, motorcyclists, because you're not given the data. If you've got the data, it is what it is. There is a right and wrong for this if you're given the data. So use that scoring reference. But it's good. So now we've got numbers across the top. Now I'll pause there, Kathy, and see if there's any questions.
No, we're okay at the moment, Ken.
Okay. Right. So let's go now to likelihood. So as I mentioned, exposure, pretty clear cut. You just need to understand exactly what the numbers are or make a prediction on it. When we get to likelihood, it is somewhat more subjective. And this is relying on your experience, your judgment, your knowledge, your understanding of what presents the chance of crash at intersections or lengths of road. And this is sort of what you were practicing doing in your last assignment. You did a pretty good job of it, most of you. You're pretty good at likelihood. People were talking about you know, sight distance issues at the intersection, skewed angles at the intersection, see-through effects, lack of lighting, bad signage, all of these sorts of things. So what you do in your safe system assessment matrix there is you don't just sort of say, oh, I reckon it's about a 1 or about a 3. No, you actually have to justify this and point out things that are influencing your scoring. So for run-off road, it could be things like the speed, the geometry, the shoulders, barriers, the hazard offsets, the delineation and guidance, and many other things could be influencing it. And you will point these all out, the ones that you see out there. You go, oh, it's a high speed, so that makes me want to make the score higher. And it's, oh, but it's got a really great geometric alignment. The lanes are appropriate width. It's got audio tactile edge line. It's got sealed shoulders. It's got, you know, all of these things which make me want to land on a particular score. But let's go over and see what we can get for this scoring. So let's go up to a 4 again, the worst. The likelihood of individual road user error leading to a crash is high given the infrastructure in place, e.g. high approach speeds to a sharp curve, priority movement control, filtering right turn across several opposing lanes, high speed. So the 4 is generally seen as some pretty significant infrastructure failures in terms of things that are going to significantly increase the likelihood of people crashing. You know, people having to make turns across multiple lanes based on their own judgment and call, we know that that's going to be pretty bad. We know we're going to see a high likelihood of crashes there. We know if we've got a sharp curve after a long straight and it's got, you know, adverse crossfall or something like that, adverse super elevation, it's going to be bad. We're going to see a lot of people running off the road there. So that's a 4. What about a 3? It is likely that a given crash type will occur. Well, it doesn't give us a huge amount of information. 2, it is unlikely. 1, it is highly unlikely. We're not getting a huge amount of information here. And the thing is that we're sort of doing this at a relative level compared to other intersections in New Zealand or other lengths of road in New Zealand. We do have a fact sheet on this because it's really it's not super helpful. If you took it absolutely at face value on an individual intersection perspective, everything would be 1 or a 0 because the chance of a crash is highly unlikely. So you need to do it at a more relative scale. Now, I haven't been talking about 0 yet because I kind of leave that to the end usually. Because, well, I will leave it to the end. I'll come back to zeros. We don't use zeros very often, is the reason. Okay, so we're making this call on the likelihood of crash. And maybe we've got really great, we're really happy with all the infrastructure and the like. The speeds are a little bit high, but it's got sealed shoulders and audio tactile and all of these sorts of things. And I go, well, I think, you know, in a relative sense, it's unlikely that a given crash type will occur compared to, you know, other areas. I'm going to go with a 2 there. Then you do the same for head-on crash. Now, head-on, you might be thinking slightly different because you might be thinking about what's the separation. Is that audio tactile in the center line as well? Yeah, maybe a few other things. So maybe, in the head-on is probably the only point you will, one of the only points you will factor, you can factor volume in again. So the AADT up here is the amount of vehicles that are exposed. That AADT will also influence the chance of a head-on crash, the likelihood of a head-on crash. But let's go with a 2 as well on this one. and we'll go intersection. And this is where we're looking now at, well, is it signalized? Is it not signalized? Is it a roundabout? Is it a give-way control? What are the angles of the legs of this intersection coming in? Is it easy to see the intersection coming up? Is there a see-through effect? But how are we managing conflict points? What's the surface like? All of these things are in there about the intersection influencing vehicle-related crashes. Maybe we look at all of that and we say, oh, we're not too happy about this this intersection. It's got give-way control, and it's got this sort of half sort of slip lane, acceleration lane, which isn't long enough to do anything, but commits people to making that move, and then the angle that they've got to look back on is really bad, and the sight lines to it are not great, but the speeds are medium. Maybe it's 70-kilometer approach to it. It's got these good aspects. It's got good lighting. It's got good. So we look again here and we're saying, this is unlikely, likely, highly unlikely. It's got a lot of, really fundamental issues. I'm going to go with likely. I'm going to say it's a 3. I'll put a 3 in there, but I'm going to justify it by not pointing out all of those things that I'm noticing after looking at it. We go to other and we start to do the same. Well, if you've got 2 lanes, that's going to help facilitate sideswipe crashes, isn't it? 2 lanes in each direction. 1 lane is going to be harder for that, or you might be thinking about other things. We're going to go 2 on that one, and got to point out all those bits of thinking. Pedestrians, you're going to look at, well, what pedestrian crossing facilities exist? What's the, are they on the pedestrian desire line? What's the length that they have to cross? Are they curb out stands? Have they shortened that down? How many directions of travel are they crossing? Speeds, all these sorts of things. We'll look at that and we analyze and we come up with a decision on that, and maybe again we dot point these out and we get a score of, let's go with 3 on that as well, just because the speeds are up, and maybe there's a pedestrian refuge island and there's good lighting and there's good things, but the speed's high, so we've got a challenge there. Cyclists, where we look at it and we go, well, there's no cycle lanes, there's no off-road path, there's absolutely no facilities at all for cyclists, so we're going to go a 4 there, even though we know that there's not a huge number of cyclists going through there, but we've taken that into account. We're just like, for a cyclist that is going through there, what's the likelihood of crash in a relative sense for them? And motorcyclists, well, motorcyclists are, you're trying to now factor in a whole lot of different things, because motorcyclists, that'll be intersection crashes, run-off road crashes, other crashes, sideswipes and the like for motorcyclists. So they end up being really as high, if not higher, than anything you're getting in these ones. So I'm going to give it a 3. Okay, so we've got scores now for the likelihood, and there's subjectivity to it. You just saw me being subjective. Now I'm doing it just in a very quick sort of demonstration, hypothetical type way. You'll do it in a lot more detail. You do more thinking. You'll do more justification by writing it in. And what we sort of tend to find is that road safety auditors, or people who have been doing those road safety audits or crash reduction studies for that matter for a long time, really are very comfortable in this space. They're comfortable in doing it because we've been making judgment calls on this forever, like the chance of crash. We often have exposure packed into our sort of calls on that. So you've got to learn, got to recalibrate your brain to extract exposure out and just think about the likelihood. But really think about the numbers, the 0, 1, 2, 3, and 4 as low or very low, low, medium, high, very high. Okay, so they're sort of, if you think about them in that way, it sometimes calms people down a little bit. They get very nervous sometimes and very particular about putting numbers to things like this.
Can I jump in with some questions, please?
Please do.
Would you ever refer to the crash history to assess the likelihood?
I would not. The reason I would not is that the crash history is the product of exposure, likelihood, and severity. It's not just likelihood. What's a good way of explaining that? You may have an area that has no crashes. And that's because the volume is low. You just don't have it. Your likelihood might be extremely high compared to other areas and the like. You've got nobody going through there. And the severity could be really bad or good or whatever it is. But to take the crash history and pick only one aspect of risk, being likelihood, is not appropriate. So what you could do is, after you filled out your whole matrix and you multiplied it through, then you could look at your crash history and you could look, is this looking about right in terms of the proportion of different crash types in this area? Hopefully that clarifies that.
Thank you. And we're going to go back a little bit to exposure. The exposure for cyclists and pedestrians seems low. If you're in an urban area, you would expect there'd be hundreds of pedestrians, but this isn't reflected in the exposure. Why are the thresholds for cyclists and pedestrians low? Seems more realistic for a suburban and rural setting.
So the threshold numbers, being sort of 10, 50, 100. That's one thing that there has been a lot of debate and commentary about within the road safety engineering community and those doing safe system assessments, because it often does come out as a 4. It's what Austroad said, and so far nobody's come out with anything different. We've pondered it, scratched our head, and we've said, no, we're just going to run with that at the moment for lack of a better set of numbers. But you may, certainly in metro settings and the like, pedestrians and cyclists very often come out as 4s in terms of exposure, and that is what it is. So
Okay.
it's a good thing to have spotted and to understand how that sort of might play out. At the moment, it is what it is. We give a prize to that person.
Okay, great. Thank you.
I realise this session is very poor for prize giving.
All right, ask questions, you'll get a prize possibly. That's all for now, but keep the questions coming through, and I'll let you carry on with severity.
I'm going to finish severity, and then I'm going to give people a chance to have a coffee after we've absolutely made a mess of this slide.
Okay.
Okay. So we go now. Right. We've scored exposure. We've scored likelihood. We get to severity, and severity sits somewhere in between the two in terms of subjectiveness. So we have our chart, so that's pretty clear cut. However, you need to make judgment calls on prediction of crashes that are going to happen, and the speeds they're going to happen, and the angles they're going to happen, and who's going to be involved. So you're still making real judgment calls, but you've got the advantage of going to this chart. Once you've decided, you go, okay, I'm worried here about a car hitting a pedestrian at this location, and I think it's going to be generally they're going through there at this speed. Maybe some will be a bit higher end, even the crash scenario is more likely to happen, but I think it's going to happen somewhere in the sort of 60 to 70 kilometre per hour range. And we go, okay, and here, 70 kilometre per hour range, somewhere in here. And we're, sort of really sitting in that high 3s to 4s. I'm going to go a 4. So that's sort of how you make your judgment calls on that. You go back to here and you look at the written definitions in the scoring reference sheet. Like a 3, should a crash occur, it is likely that it will result in a fatality or serious injury to any road user involved. Kinetic energies are moderate, but are not effectively dissipated before reaching the road user. What does that mean? Effectively dissipated before reaching the road user? Well, that is cushioning, so crumple zones, airbags, seat belts, helmets, inflatable jackets, whatever way that might be, pole protectors or the like. It's a barrier system or something that runs out the energy and dissipates the energy over time. So the car hits it and slides along it and dissipates the energy before it reaches the road user. For a 4, should a crash occur, it is highly likely that it will result in fatality or serious injury to any road user involved. Kinetic energies are high enough to cause fatal serious injury, and is unlikely that the forces will be dissipated before reaching the road user. Here we see unlikely for a 2, highly unlikely for a 1. But we've helped you out with the chart there. So use that, go through and you dot point out your things in severity. Now, severity of runoff road crash is going to be influenced by speed, definitely. The road side becomes, I suppose, quite an area of, dot points you'll put in there. Barriers, is it trees, is it houses, is it culverts, is it ditches, swale drains, what is it? What's the severity going to be? Are we worried? Are you saying, well, it's a cleared area, but rollover, it's pretty sort of rough ground, it's rollover, but that's going to be less severe than hitting a pole or a tree or abrupt stops on a culvert. So you're thinking all of this through. Are they slip-based light poles? How many slip-based are there compared to rigid? So it's, which ones of those are they likely to hit? And you sort of come up with your answer there. So maybe we've got in this one, we've got a nice cleared area and then a barrier system sitting back 4 meters from the roadside. And it's a flexible barrier system. And so we're really quite happy with all of this, and we're going to go maybe to a 1. Head on. Now you're really looking at speeds and the percentage of heavy vehicles, because heavy vehicles are going to be more severe. Speed is going to be your big factor here. And yeah, we might be saying, I'm going to go, well, I think they're going to happen around the 70 kilometre per hour mark, a very low percentage of heavy vehicles. So we're talking about passenger vehicle to passenger vehicle, head-on crash. Okay, that's right down here. Head-on crash, car to car, somewhere around the 70. Let's see where that's sort of going to go. Okay, we're in around somewhere in the 3 range there. I'm going to go with a 3 for that. Intersection. Now we're thinking about the intersection, the angles of impact. This is vehicle to vehicle, angles of impact, speed, the bullet vehicle speed. And I'm thinking, okay, we've got an intersection crash. It's going to be a right angle. Still thinking around that 70. They've done nothing to lower speeds at the intersection. So we've got side impact, car-to-car side impact there. And somewhere in their 70 range. Now we're at the high end. Okay, do I go at 3? Do I go at 4? I debate with my team. What do you think? Yeah, no. probably the ones that are crashing might be putting the foot down to get through there, or yeah, now we're going to go a 4. Got to go 4. And other, well, side swipes are very minor severity in most situations. Some other rear ends and things can be bad, but I don't know, you might decide on a 2. Speed's going to be a big factor. Pedestrians are really going to be speed. Is going to be the big influencer there. What's influencing the speed? Well, it could be other things to slow vehicles. Are there raised features? Are there speed limits in place? What is influencing the speed? But we're going to be a 4 in there because that's going to be pretty bad. Cyclists the same, they're going to be bad. These are vulnerable road users. When they get hit at speeds above, well, we can go to the chart and just see it. I mean, first time that a vulnerable road user sort of even enters the scenario is here. So it's going to be sort of very bad. And motorcyclists, yeah, you might look at it, factor it in a few other things, and maybe make a 4 there as well. Again, though, in each of these cells, you're dot pointing and justifying. Dot point, the speed's this, it's influenced by this. We think, maybe you've got 85th percentile speeds, but you say, well, but high-end speeders are going like this, and getting your intel that way, and these features are influencing that. There's raised platforms, there's a roundabout, there's the road narrows in this section, different things to influence the speed and the severity and the angle of impact and the frangibility of roadside hazards and those sorts of things. So you've got to a wonderful point where now you have numbers in all of the cells here. And what you do then is you multiply. I better change color here. Because people will not be able to see it if I put more red in. Multiply. And you multiply down. So you multiply your exposure by your likelihood by your severity. So 2 times 2 is 4, times 1 is 4. And that's our runoff road score. So 2 times 2 is 4, times 3 is 12. So we've got then our head-on score. And you keep doing that throughout. So 24, and this very quickly, 8, 4, 8, and you go through and multiply them all that. So that then gives you your score for each crash type. And then what you can do, and you do, is you add up along the bottom here. You add the bottom scores to get a final score out of 448. And see under there, it's too much mess on the screen now, but you get the idea, I'm sure. Multiply down, add across the bottom, final score. Now, Kathy, I want to talk about using zero in here, but I think it's time for a coffee break. But can you remind me when we come back to talk about zero?
Yes, absolutely, I can. Can we do a quick question?
Yep.
Is speed for head-on double the operating speed? Is the operating speed or double because each vehicle would be doing the operating speed?
No.
We're going to refer back to that Mythbusters episode. Yeah. Okay, John, I'll refer you to the Mythbusters episode on that one. And a different John is having a problem with the slides have frozen. It might be an opportunity, if that has happened, to do a shutdown, restart and reconnect, and hopefully that fixes things, and a break is a good time to do that. How long, Ken?
3.5 minutes.
Oh, jeepers. Okay. Is that how long it takes to boil your kettle? Okay. 3.5 minutes. Thanks.
See you shortly. Excellent. Okay. So look at the mess we've made on this slide, and that's great. And you'll do it in a much prettier fashion because it's a nice word template and you can put nice dot points and the like and get some numbers out the bottom and add them up and get a score out of 448. I said we're going to talk about this zero. If we go to our scoring reference sheet, the Australia scoring reference sheet, says 0. There's no exposure to a certain crash type. That may mean there is no side flow, no intersecting road, no cyclists, no pedestrians, or no motorcyclists. So this may mean that you're dealing or assessing a bit of road that doesn't have intersections. Okay, it's a mid-block section of road. Right? And the exposure to intersection crashes is 0. Or you may be doing a motorway or something and you actually have no cyclists on the motorway. There's the ban and cyclists on the motorway, and you've checked and talked to people and said, are there actually cyclists using it? I know they're not allowed to, but do they actually use it? Because we're real world here. We're not, if everybody follows the rules. But if they say, no, it's, the occasional Dutch tourist that arrives with their bike on the plane, decides to ride it down there, but that's so, maybe a once every couple of year event, and it's really, no, they don't ride on it in general. You go, right, a 0. Now, how do you deal with that Dutch tourist or that possible scenario? There's actually a little bit more in the safe system assessment where we can deal with weird and out there things like that, and look ways to treat that. But, so that's exposure. So if in this scenario, we did not have an intersection, we put a 0 in exposure to intersection. We need another color, I think. Put a 0 here. And then what happens when you multiply anything by 0? Well, it's 0. So that whole column is just going to be wiped out as a 0. And that makes sense. You don't care about the likelihood or severity because there's no intersection. That crash does not exist. If you go to here and you go to likelihood, now there is only minimal chance that a given crash type will occur if an individual road user error given the infrastructure in place. Only extreme driver behavior or a substantial vehicle failure could lead to a crash. Now, it is extremely rare to use a 0 in likelihood. Okay, you'd more often, if everything's looking really great, you'd use a 1. And the reason for this is that we are taking into account all of that natural human failure, distraction, falling asleep, these sort of things. Those are not extreme behavior, right? So yeah, the idea of using a 0 in likelihood is few and far between. I've done hundreds of these assessments in my time, and I think only once ever used a likelihood 0, and that was on a shared user path. But in theory, if you put a 0 in the likelihood, right? Again, multiplying anything with a 0, it's going to wipe the whole thing out, and that makes sense because if you can say that no crashes are going to happen, you don't care how many people are exposed to it and how bad it's going to be because there are no crashes going to happen. So it wipes a whole column out. And if we go to severity and we say, should a crash occur, there is only minimal chance that it will result in fatality or serious injury to relevant road users involved. This might mean that energy transfer is low enough not to cause fatal or serious injury, or that excessive energies are redirected and dissipated before reaching the road user. Users may refer to safe system critical impact speeds for different crash types while considering impact angle and roadside hazard barriers that are present. Lots of words. Our chart's got 0s in there, sort of, anything in that sort of range. You might give it a little bit of more. These are graded, so you might be able to get 0s in here, and that again makes sense because if we're able to say, well, it's a 0 here, well, we actually don't care how many people are exposed and what the likelihood of it is, because when all these crashes happen, nobody's going to be killed or seriously injured. And that's our objective under the safe system. Okay. Now, little disclaimer on that. If you had 4 and 4 and 0, yeah, okay, you get a 0 out of this and it wipes the column out. However, you've probably got I suppose, a traffic engineering road operations issue, because you're going to have lots of minor, bingles happening and annoying things. You don't want that, but from a pure safe system lens, all right, well, we've got lots of that happening, but people aren't being killed or seriously injured, so that's a win. Okay, so that's the matrix, and you have to fill that out. That's going to be your next assignment, is to fill one of these out in detail, and there's a fair bit to put in it. And here's an example of a sort of scaled back one, but how they would look. Now, don't worry about the words and reading everything in there, but you see that there's words in there. It's not just a number. And in fact, it's words. And when we get into likelihood and severity, we got pointed into things that increase the likelihood of crash and things that decrease the likelihood of crash. And you do the same for things that increase the severity of crash and things that decrease the severity of crash, and dot point those out. Okay. The first thing you do in a safe system assessment is always the existing conditions. What is currently there? So we're going to say to you, okay, here's an intersection around the corner from your house. And here's a design to upgrade it to a roundabout, for example. But the first thing you're going to do is not look at the roundabout design. You're going to look at what's currently there. Oh, it's giveaway controlled. Okay, it's got this, it's got all these features, and you complete this full matrix out based on what is currently there. Then you go through all of this, and I'm going to give you a little sort of example of it, but I won't go in detail. Before I jump into that, I'm going to take a little tangent, and I'm going to point out something that is in here. You may or may not be able to see that, but it is a 0.5. And I'm sure some of you were pondering this at some point, maybe waiting for me to say whether you could or couldn't use decimal places. If you must, you can use a 0.5. You can use a half. You can't go more precise than that. Why can't you go more precise than that? Well, there's a few reasons. The first one is, I've just shown you that there's a fair bit of sort of subjectiveness to this, and we want to keep it as a broad brush assessment. We don't want to pretend that this does some excessively precise assessment. This is broad brush telling you how it aligns with safe system principles. The second one is that we don't want to give people any false hope that their minor little tweaks to their project magically makes it highly aligned with safe system principles. So it can be really an effective tool when somebody comes up with a design, and it may be a high-speed intersection, signalized intersection, and it gets scored and it doesn't perform very well. It gets quite a high-end score, and they say, oh, okay, well, we're going to put up warning signs on the approach to the intersection. You go, okay, great. And you say, well, we'll rescore it. And you go to rescore it, and you go, yeah, that's not even enough for me to change the likelihood of intersection crash by, a full mark or even a half mark. So the end result of them putting up those intersection warning signs, when we have a fundamental inherent issue of a high-speed intersection controlled by traffic signals, gives no benefit under the safe system assessment. Now, that's, in theory, it's wrong because it does give a very small benefit. But it really reinforces you've got to do something more. We've got to do more than just put up some warning signs. Anyway, there's a couple of reasons why. And yeah, so you can go to a 0.5. We discourage it, but if you absolutely need to, more often than not, you end up in a 0.5 is because your team can't decide between a 2 and a 3. Your assessment team, and you're debating it, you end up compromising on a 2.5. So anyway, existing conditions. So, you've got some sort of existing road and you've looked at it and there's the intersection and you've looked at, okay, it's got power poles here and it's got drop-offs, got a footpath. It looks to have, it's got some lighting, so that's good. It's, a lot of these other bits and pieces, and you've made the calls on it. And then you've done that existing conditions assessment. And then you get your design and you go, okay, I want to build a roundabout here. Or they're trying to decide, do we build a roundabout? And here's their roundabout design. It's actually a nice stage to be doing a safe system assessment because you've got a bit of information. You can sort of see how it'll all work, but it's not so much that they're not willing to change their project. If you get the 300-page design set, and they really do not want fundamental changes to their project at that stage. So this is good. And then here's a modified T intersection signalized is their second option that they're trying to decide. And there's the conventional T intersection with slip lanes as their third option. So you've got your 3 options. And what you do is you go back and you get this existing conditions matrix. So that was what's there before the design. It's all filled out. You're happy with it all. You've put lots of information in there. You've got all your scores, and you copy the whole table, and you paste it, and then you modify it. And you modify it by crossing out factors that are removed if they build the roundabout design exactly how they've given it to you. And you put in a different color, usually people use red, new things that have appeared, new things that make you want to make scores go up or down. And then you color the scores that change. And so anybody looking at it can clearly see, okay, that's gone, that's new, that's been included, that's better, that's worse. Okay, there's a score change there. And Kathy will show you in our little one that you've got to, you're going to put in the original score and then the new score, I think. Well, we'll show you that in the thing. But so you alter the existing conditions on the matrix. Then you do the same for your next one. So again, you get the original existing conditions matrix, copy it again, paste it, manipulate it, modify it, add bits, changes, new scores, color them, conventional T, and you get all your new scores. And then you're able to come out with final scores. And so you're able to say the existing conditions, 118.5. If a roundabout is built as per design, that drops down to 90. And remember, lower scores are better. Modified T, 99, T intersection, 105. So we know that the roundabout gives us the highest alignment with safe system principles in this project. Anything that they do there, any of their 3 designs improves things from the existing conditions. And with all of them, we could do better. Nobody got a 0. None of the designs got a 0. And you might want to chart that some way if you want to do it like that. But then this is what we produce. And this is what I showed you an hour ago. And we've shown you now sort of how you arrive at that and so how it can tell you a story immediately. Now, none of those got 0. And in fact, I've never seen anything get 0, as in total score. And the safe system is this, spectrum, and we're trying to get us towards 0 with these scores. And so what we're going to do is for every design that we are presented, and if they give you 3 concepts, or they give you 30 concepts, it doesn't matter. You are going to make recommendations to them on alterations to their design that will get their scores lower. So, they might be doing a roundabout, and you might say, yep, okay, in that example we were looking at, the roundabout came out as the best score. However, cyclists were not very well. So why don't you consider an off-road cyclist facility around the roundabout? Why don't you consider a Dutch style roundabout? Why don't you consider maybe speed cushions on the approach so that the cyclists can enter in and claim the lane just in front of the point where vehicles have to slow to go over this raised treatment, or whatever you decide. Could you say needs lighting improvement, do better skid resistance work, or anything you've decided that could improve alignment with safe system principles. And each of those things need to be categorized. So when you say improve the lighting, we're out there, the lighting's bad, you've not indicated in any of your designs you're improving the lighting, you should improve the lighting. Then you need to say, is that a primary treatment or a supporting treatment? I'm just going to draw a line there now, because non-safe system is more there for terminology. But is it a primary treatment or is it a supporting treatment? Now, a primary treatment is any road planning, design and management considerations that virtually eliminate the potential for fatal and serious injuries occurring in association with a foreseeable crash type. So it doesn't say, eliminate the crash type, but although that might be the way to do it, but the potential for fatal or serious injury. A supporting treatment is any road planning, design, management consideration that improve the overall level of safety associated with foreseeable crash types, but not expected to virtually eliminate the potential for fatal or serious injury occurring. And another little one there, it does not change the ability for a primary treatment to be implemented in the future. But really, this is going to be a challenge for you to get your head around this. First thing to note is that primary does not, in this case, mean your number one treatment. It's categorization. I think the term that they picked there has caused people a lot of trouble, because you might have 3 primary treatments, or you might have no primary treatments. It's just a categorization. So the things that categorize as primary treatments usually are raised crossings, raised intersections, roundabouts, flexible barrier systems, those sorts of features that we know are, virtually eliminate that particular crash type that we're worried about. And they do it by reduction in severity and likelihood. To solely rely on a likelihood reducing factor, so, more signs, more warning, traffic signals, clearing sight lines and anything like that, they're not primary treatments. They are supporting treatments. They're good things to do, don't get me wrong, but they aren't going to eliminate, they're not going to virtually eliminate the crash type. Now, you have to think about this as crash type, not the issue. And let me explain this briefly. So if you have an intersection and it's a giveaway controlled intersection and it's got sightline impediments, I don't know, we'll go parked cars, okay? Parked cars mean that you can't see as a driver when to go out or not, when it's safe to go out. Removing all the parking and opening up those sightlines, that is a supporting treatment, okay? Yes, you've removed that thing you were concerned about, but have you eliminated the potential for fatal and serious injury intersection crashes? No, right? You've just lessened the chance that they're going to happen because people can see. So it's a supporting treatment. Now, there is a little bit of help for you. The Austroads guide, the Austroads Safe System Assessment Framework document actually lists a whole lot of treatment and categorizes them into primary and supporting for you. And Kathy will show you that shortly. And the last thing you do is talk about, you don't score these, but you answer these qualitative questions about wider elements of the safe system. Now, the safe system isn't just building infrastructure, it's the whole system. So they've put these prompt questions into Austroads, and we make some comments where we can around them. And it may spark some ideas on alterations to the project or initiatives that could help us. Now, we're not going to make you do this in the assignment, but if you're doing full safe system assessments out there, you would go through this. So the questions are road users likely to be alert and compliant, and are there factors that might influence this? What is the expected compliance and enforcement levels, alcohol, drug, speed, road rules, driving hours? What's the likelihood of driver fatigue? Can enforcement be conducted safely? Are there special road users, entertainment precincts, elderly children, on-road activities, any distraction by environmental factors or risk-taking behaviour? So you'll be dot pointing out what you know. You might want to you'll talk to the project team, maybe. You'll talk to the local highway patrol if you're doing this in a comprehensive manner, and your client, gives you permission to talk to these people. Or you might know a lot about this area, and you can really start to build up a bit of a picture. Some of these things may slightly influence your matrix scoring, some definitely may not. Some you may just not have much information at all, okay? But at least you're thinking those through. Then you do the same for vehicles. What level of alignment is there with the ideals of safer vehicles? Right, what a broad, random question for an infrastructure project, Well, the reason that's in there is, you remember right at the start, I said that this is very versatile, scalable assessment that can be used in different scenarios. That one is really aligned with the idea of undertaking a safe system assessment on a remote community or a mine site or something like that, where you can analyze their fleet and understand the vehicle fleet safety features and those sorts of things. To do this at an individual intersection level or a road upgrade level, it's not, you end up sort of just going, not really applicable. You might start to delve into a little bit of roads that cars can read, vehicles of the future. Are we enhancing safety features? Is there vehicle to infrastructure communication? But it's all a little bit abstract at the moment. So more often than not, I see that as not applicable or nothing, nothing of note here for normal intersection upgrades, road length upgrades and the like. But the advantage of having these sort of questions is you sort of sit back and you ponder and you think, is there anything? I don't know. Are there factors that may attract a large number of unsafe vehicles? Is the percentage of heavy vehicles too high? Is the route used by recreational motorcyclists? Are there resources to detect non-roadworthy overloaded unregistered vehicles? Can enforcement activities be conducted safely? And that one does often play out and is quite interesting to work through. Has vehicle breakdown been catered for? And then finally, post-crash care. Are there issues that might influence safe and efficient post-crash care in the event of a severe injury, congestion, stopping access? Do emergency and medical services operate as efficiently and rapidly as possible? So those are the ones where you start to get some interesting ones. I know there was a bit of controversy about some of the helicopter landing pads on the Coromandel area to extract the injured motorcycles. That actually came about with some of this, the safe system assessment methodology hadn't quite evolved at the time, but we were over there and there was some workshopping and with others, and they were we were thinking around this post-crash care. They're the kind of things that sometimes spark as thoughts. Is there phone reception? Can people get to injured parties as quickly as possible? Are road users' emergency response teams protected during crash events? Are drivers provided correct information? Is there reliable information via radio, VMS, etc.? And again, another one which is a bit more around the vehicle safe fleets and those sorts of things. Is there provision for e-safety? So things like safety systems based on modern information and communication technology, cooperative, intelligent transport systems, and those sorts of things. Again, you may get stuff out of this. If you're doing a massive safe system assessment on a new tunnel or something like that, you're really going to delve into these in big ways. If you're doing a minor intersection upgrade, a lot of these might be, no information, not applicable. But yeah, they're there and you ask them. Okay, so this is sort of what would be expected in a safe system assessment report, but luckily we're in a position now where we just give you a template. So if you follow the template, use the headings of the template, you are meeting sort of what Austroads would require and the different governments would require. So we will give you that template. We've put actually full templates and short templates into the learning management system, so you can download those in Word. You're welcome to rebrand them, and they're not our brand actually. That one's our brand there, but they are actually Victorian government brands, and the Victorian government's clearly said, yes, please, just put your own brands to it. Just everybody use these headings and fill out these sections, so we've got it all same. So rebrand it, go nuts. Just please make sure you put all of the correct information in. And this is your assignment, and Kathy's going to sort of live show you all of this, but I'll do a little high level thing to say that anything highlighted yellow, you're going to need to change, all right? And before Kathy takes over the screen, let me just say, you're going to go out to a site. Now, we've looked at all your sites. The sites are low risk, and we've done that for the purpose of ensuring your safety. However, we still want you to wear a high-vis vest, and there's no need to be measuring lane widths, putting your head down to look at the drainage and anything like that. You are there to just observe the intersection under this particular lens of understanding safe system alignment, how people are using it, and the like. Don't be a hazard yourself. Don't make people walk onto the road to get around you. Don't park so that cyclists have to go into other high-speed lanes. We looked at all these sites again. There's areas where you can park safely away from the intersection and go there. And we have prepared a safe work method statement, which we're going to ask you to complete. There is nothing in here that is out of the ordinary. It says simple things like, yes, I will not go out there while I'm intoxicated, and I understand that, well, we've done all the risk assessment and made sure these sites are safe, that I will be, conscious of my safety, and I will, act appropriately. And you're all in the space, you know how to do this, you know how to be safe, and do it in a safe manner. So you'll need to acknowledge and accept that as a little one question poll. Over to you, Kathy. And there might be some questions already, yeah?
Yeah, no, it was a really good pickup, because the scores in the presentation version in the learning management system are not there. That's all right, all good. I'll fix it after the session. All right, so we want to go straight into the assignment?
Yes, we do.
Yes, we do. Okay, here we are here. So we're at module 4. There's that presentation that I'll fix up shortly, and you go to complete your safe system assessment. Your template is there, and there's also a graph generator there available for you as well. Your site is here with your name in there, and it's due in 2 weeks' time. So we'll just jump into it. We can see that okay, Ken?
Yeah.
Great.
Enable editing, enable editing.
Sorry. Good one. So it looks like we complete only the highlighted sections. Is that right, Ken?
Only the highlighted sections.
Okay. It's in there a second time. So we've got some bits crossed out here, so we don't have to worry about those. We just, yep.
We tried to streamline it because we really don't want people spending weeks on this. We want just show us you understand. Yeah, tell us who you are.
Good. If you do it as a team, put every person's name in this section here.
And we're okay with you doing it as a team if you know, the same site and the like. You both got to, or all three or both have to submit in the portal and tell us that you're a team, and you know, you've got your tests and things, so we're your individual tests and things, so we know that. But anyway, yep, keep going.
Sorry, what was that?
Yeah, keep going. Doing well, Kathy.
Oh, okay. Are we here? Proposed works. Proposed
Yeah,
summary?
proposed works. Yep,
Yeah.
yep.
Oh, sorry. Yeah, I wasn't sure if you were going. You jump in.
Okay, I'll run with it. So we want a very brief description of the works that are happening. Okay, and then we want you to tell us the speed limit and put a snip of your design. So you've got the design, so it's there, so it's easy to see. And then, yeah, people have in the past written us pages and pages about the site. I mean, that's, yeah, nice. We're not going to read it all. You know, you just need to say, this is what it is, this is what's happening, and here's a snip of it. Speed limit, existing speed limit is this. And then you do this little section 3.1. You do sort of after you've done your matrix and your scoring, but this is sort of summarizes the end scores and the outcomes. So you can go down a bit, Kathy. You need to put that graph in. You saw me show the graph twice, and Kathy has mentioned, to make your life even super easier, we've given you a little Excel graph generator. I mean, you all would have been able to do this yourself. We've probably saved you 10 minutes maybe, but you simply can put your scores in, and I don't know if that'll work without enabling editing again, but it may. And you just plonk your scores in, and hey presto, the hopefully, yeah, there we go. It's starting to appear with little numbers. So you can do that, and you can use this for future ones if you want as well. Of course, and there's tabs down the bottom if you have one design, two designs, three designs, and it gives total scores, and it just helps you with representing that stuff. And I love the snipping tool. I use the snipping tool all the time because I don't have to mess around with formatting. I snip, there we go, and then I paste it into the Word document, and off we go. Down a little bit further, but you know, this is really where you're going to have to do things. You're going to have to do them first. So this is where you create the existing conditions, and you're going to write in there. So this is where you look at what is currently there. Put the design to the side. Don't worry about the design yet. What's currently there, and what is the exposure? What are the traffic numbers? And then what's the score for that? And then you put the score there in existing, right? Because this is existing conditions. You ignore design one for now, okay? Ignore that for now. And you put your score in. And then you do the likelihood, and you put dot points there. What are the factors that increase the likelihood? High speed, no sealed shoulders, poor surface condition, no lighting, blah, 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 dot point, dot point, dot point, dot point, dot point. Okay, what are the things that decrease the likelihood of crashes? I've just run with a whole lot of things that increase. So I've got not geometric alignment's good, you know, good sight ahead, good signage, whatever, you know. And so you do all that, and then you put a score in the existing there for, yeah, okay, good, a 2. There you go, perfect. Okay, so we've got that. And then we do severity, same thing. Increase, high speed, yeah, good. And things that decrease are, what are we doing on? Barrier systems, you know, it's got barriers. Or flexible barrier systems or something like that. And we come in with a, yes, the score existing conditions 2, or whatever it is. And and then you multiply that out. What do you put there? 2, 4, 8. Good. And there we go. Well done. So you do that for all of them. You leave the design one blank because this is your existing condition score. You put your existing condition score out of 448 in there. And so you've added across the bottom. There we go. And hey presto. Then you copy that.
So just showing here, have you got the example one? This is
Yeah.
the example one. So we've just popped in there an example. So what yours should look like, but your own commentary in here.
Yep. So you've got nothing on that design one. It's all filled out nicely. Then you're going to copy your filled out one. You're going to paste it. You delete those example ones. Yep, you're going to copy that. Beautiful. You're going to paste it there, are you? Okay.
Yeah, that's good.
And you paste it, and then you're going to cross bits out. You're going to, yeah, maybe do a strike through on one of those. Yeah. Okay. Yeah, that's going okay because we're sealing the shoulders or whatever it is, and maybe something new goes in there. Yeah, maybe sealed shoulders. Put sealed shoulders there. Yeah, look, and wrote it in red. Beautiful. And we change, and then we put in there the design score. No.
Whoops. That's how easy it is to get it wrong. The design score is now
1.
Yeah.
Good. And you can make that red.
So what we're really looking at here is the differences between our existing conditions and what our design does. Yeah.
Correct.
Okay. And chances are, have we changed the exposure up here? Probably not.
It'd be pretty rare that you change the exposure. And yeah, you fill all of that out, cross that out, and maybe that might stay the same. Let's say the severity stays the same. It's still a 2. And then you wouldn't need to color it. You just leave it black. And then you get your final score, which will now go to a 4. And that will be, there you go, Kathy, getting lots of marks for your wonderful safe system assessing. We'd need a lot more dot points than that on how I've arrived at that, but you get the idea there. And you're just going to do you're only giving one design option, so that will be it. Delete those other examples. They're just there so you know what you're trying to achieve, and then fill it all out. Yeah, get your final score there. Well done. It'll change 116 down to 92, and that's given us a. Once you've filled all of that out, that's when you go and you use the Excel chart generator and you generate your chart. You put that in, and off we go. So this is what it'll end up looking like. Although, have we? Yep. Go down a little bit. Yep. And you can see the numbers have changed. The numbers have changed. So delete those all after you have finished, and
the
final thing.
Delete the examples. They're just there to help you along your way. Yep.
Exactly. So what we will expect to see is 2 matrices, 1 for the existing conditions, 1 for the design. That is all. Then for that design, you say, here are some things that you could do to improve that design, right? Not improve the existing condition, improve the design. It could be alter the design, lots of significant changes. And you put them into primary or supporting. So you might say, include a separated shared part, and that would be a primary. And then you might say, add a raised crossing, and that would be primary as well. Look, there's 2 primary things. It's not like one's a primary and one's a secondary. No, it's primary meaning just that categorization. And then improve lighting, because we don't think the lighting is bad. Not that, as Kathy types that, we don't want you going out there at night. So don't go out there at night. I just said improve lighting because it popped into my mind. So there you go. You can unhighlight the things as you go. It doesn't really matter, but that's that. You don't put anything in the project response. I mean, that is a standard thing there. So when the safe system assessment gets handed to a client, they can write stuff in there. They can respond. They can say, yeah, we love your idea. We can't do it though for these reasons, but we'll do this instead. Or, yep, we do. We love that. We're going to do it. I'm not going to get you to write a conclusion or anything. I forgot you put a picture of me in there, Kath. Thank you. The last thing we want is
Place Ken.
replace Ken. Please replace me. Replace the photo with you on site, because one of our requirements here in the of this course is that you do visit a site, and that really often shows you some of the advantages of just looking at a site live through the lens of this safe system assessment. You will know these sites. This will be near your area, but if you look at it in this particular lens, it can help you. So do that. Make sure you're wearing your high vis vest like I am there, and just take a photo to prove to us you went to site. We don't want to see all the photos of the site. In a real safe system assessment, you do, lots of photos to show different elements of it, different issues and the like, but just enough there. So that's nice package there. Then PDF it if you can, please. It just helps us at our end. If you can't, don't worry, just upload it as a Word, but PDF it, and then add submission and upload it. And you're all getting pretty good at that because you've done it for module 2 assignment. The quiz.
There is just another quick quiz in here for this particular module, so jump in and do that one as well. But ideally, what we're looking at is that you get out there and do your site visit in the next week, and you start writing up your report. You do have 2 weeks to submit this one. So next session, which is next Friday, which is our last session, it's an opportunity to come back with questions. Of course, you can come back with questions anytime, email us, call, whatever you like. If you're scratching your head, you're not sure where you're going with it, that sort of thing, we're here to help. So please get in touch. But otherwise, we've got next session, we've set aside some time to answer those questions.
The safe work method statement there, Kathy, click on that one. So that is the the safe work method statement for the sites here, just showing that we've had a look at them, and there's a few things we've popped in there for you to just be considerate of, all fairly low risk stuff. Then once you've had a read of that, you go to the little one question little quiz for safe work method statement. It says, you've looked at that safe work method statement. You're going to wear appropriate PPE. You're not going to create a hazard. You're not going to be drunk and the like. And click, you agree with that, and off you go. Now, as Kathy said, next session is a great opportunity to ask your questions. Go, hey, I really don't know what I'm doing here, or I've got out there, I don't know whether this is exposure or likelihood or whatever it is. We can have a good chat about that. We've got lots of time dedicated to that. The resources are going to help if you go to the Austrades one while we're doing that. If you need to book in a little bit of one-on-one coaching time, please send an email through Kathy or myself, and we'll organise that. And the Safe System Assessment Framework, which is in the resources there, is really important in assisting you. If you go down to some tables in there, because they, by crash type, help you in identifying, exposure, likelihood, and severity, but also primary categorization or supporting categorization, which are the actual 2 next colored ones. So you can see that's for run-off road crashes. You see that in the table heading, run-off road crashes. And we can see there flexible median barriers and the like, influencing severity. And we see supporting wide run-out areas, sealed shoulders and the like. So that's a good spot to help you calibrate your thinking about primary or supporting when you're deciding, do I put it into the primary table or the supporting table? And that's in there for all crash types that are in the safe system assessment. So your run-off road, head-on, intersection, other, and pedestrian, cyclists, motorcyclists. That's not all treatments. Like you'll come up, you may come up with things that are not on there, but it's helping you get a bit of a feel for what supporting is and what primary is.
And the fact sheets that you mentioned earlier here to help with scoring. So they're available here. There's 6 of them, and I'll just show you one here. So these are just the things, as you mentioned, Ken, from when they wrote the Safe System Assessment Framework to putting it into practice. And now these are the bits and pieces that people have found a little bit tricky, and we've put out these fact sheets to help people along. So there is 6 of those in there. Now, questions. We've only got a couple of minutes left. Does anybody have any questions? Anything at all?
We've thrown a lot at you, a lot of instructions there. You can watch the video this, maybe last 15 minutes if you got something, get in contact with us. The best way to learn these things, get in there, roll your sleeves up, start doing it, and come back and ask questions.
Great. All right. Well, we'll leave it there if there's no more questions. Otherwise, feel free to get in touch throughout the week anytime. Thank you, Ken. Thanks, everyone. Have fun doing your safe system assessments. Bye.
Bye. Thanks, everyone. Have fun.